In this video, we'll have a look at the state of computer networking as it was in 1994, and what a time to network your computer it was. There is a lot to talk about, but I will have a few things to demo later in the video. I'm talking from a Swedish perspective now, but I'd say 94 was the year when attention really started shifting towards the internet. Which means, whatever everyone was doing already for their computing networking at this point, it probably wasn't using the internet. Now, I wasn't around at the time, so this is all based on research. Feel free to correct me in the comments if I'm blatantly wrong about something. To try to get a grasp of what it might have looked like, let's have a look at this sample network architecture. There's a few token ring networks here, with bridges and routers to other networks. Token ring offered link speeds up to 16 megabits per second. Aside from sharing that bandwidth with every system in the ring, it performed well even on the load. It was a bit more expensive than Thin Ethernet, both in cabling and equipment. In this example, they use Thin Ethernet to connect a bunch of Macintoshes and Twisted Pair Ethernet into a hub for a mixed environment. Both Thin Ethernet and Twisted Pair at this point would allow for a link speed of 10 megabits per second. Unlike Token Ring, it did not perform well on the load, as there was no built-in arbitration. If two computers tried to transmit at the same time, you'd get a packet collision, and the transmission would have to be reattempted. This problem was solved for Twisted Pair by using a switch instead of a hub, but at this point switches were very expensive and only used to connect networks together. A distinct disadvantage with Thin Ethernet was that a loose cable somewhere would take down the whole network. 100 megabit Ethernet over Twisted Pair was on the horizon, but it wasn't available yet. I think this white line is supposed to be a leased line to a remote location. In Sweden, this would have been an E1 connection, which is like T1 except not North American. It allowed for link speeds of up to 2 megabits per second in increments of 64 kilobits per second, and was marketed by your state telco as X-Line. You could also lease fiber lines, where FTDI was an established standard at 100 megabits per second, and ATM was a brand new standard at up to 155 megabits per second. Nothing prevented you from just using ISDN or a pair of dial-up modems either though. We also see this AS400 mini computer here, which is also connected to an X25 gateway. X25 is a weird hybrid, being a packet switch protocol with extensive error checking pretending to be a circuit switch medium. Node addresses looked like phone numbers. A gateway would call a remote node and assign the connection to a physical connector. It could run on a number of data carriers, but due to protocol overhead, there was little point having a faster carrier than ISDN. Actual transfer speeds could be an order of magnitude slower than the link speed. X25 was famously known for having built-in support to build by the packet transmitted and the distance it was sent. As far as I can tell, in a computing context it was mainly used to connect dumb terminals to mini-computers and mainframes. Although Germany apparently used it for their internet backbone at the time, with less than great results. It was, and to an extent still is, used by stuff like credit card terminals, ATMs and air traffic control. Frame relay was on the horizon, which was X25 built for high speeds pretty much, but it wasn't deployed in Sweden at this point. Looking beyond the borders though, over to Eastern Europe, to Estonia. With the recent fall of the Soviet Union, it was a country trying to modernize. There, fiber optics was strongly favored. Estonia was, supposedly, the 6th largest exporter of copper in the world, despite not mining any copper. Any copper cable laid into the ground would immediately be dug up by thieves. ST Telecom's data center had 2 rooms full of old Soviet computers and a Sun server sitting in a corner. The Sun server had more computing power, memory and storage than all of the Soviet computers combined. The Soviet computers did however keep the building nice and warm in the winter though. Anyway, on the protocol layer, IPX was pretty dominant, as a side effect of Novell's NetWare being the dominant network operating system. If you talk to anything heavy made by IBM like a mainframe or minicomputer, you might use SNA over Token Ring. Other mainframe and minicomputer vendors had their own special protocols to talk to their big iron. The Internet Protocol was pretty much only used when the network was connected to the Internet. Unix systems generally had good support for the Internet protocols, while OS2, Windows and Mac OS would get it bolted on in the early 90s. Then there was LAN Manager, which was the IBM Microsoft solution to networking, which was built on NetBIOS. NetBIOS could in turn run over either IPX or IP, with IPX being the default in the 90s. IPX had a big advantage over IP, in that for small networks it would basically configure itself automatically. This was one of the big downsides of the Internet Protocol at the time. DHCP wasn't a thing yet. IP addresses, netmask, gateway and DNS servers all had to be manually configured on every computer. Previously, there was two ways of acquiring a block of IP addresses. One was just buy a connection to the internet or, in general, register a block of IP addresses with a central authority and get a block officially. The other was just grab a random range you liked and deal with it later. In early 94, RFC 1597 was published, which defined the three blocks of IP addresses were used for private networks. This was a measure to conserve IP addresses, as they were already starting to run out, and allocating unique addresses to private networks that wasn't connected to the internet was starting to look a bit silly. Not everyone agreed though, with RFC 1627 questioning the purpose of private network address spaces, advocating IPNG instead, or IPv6 as we know it today. One of the arguments against private use addresses was that you'd have to manually renumber all of your computers if you connected your network to the internet in the future. Remember, this is before DHCP. If you wanted to change addresses on a network, you had to send out a technician to every single computer. With a lot of movement happening with the internet protocol during 94, Microsoft announced that they would move to TCP/IP as their main networking protocol. As part of all of this corporate networking came a desire to run applications on it. If there is one buzzword that would define corporate networks at this time, it's client-server. Everyone was talking about it. No wonder, it was the future. Amount of client-server was projected to increase. IT managers liked client-server, although not this bank, apparently, who would rather have OS/2 on their mainframes. A trade show for client-server was held in Sweden that barely anyone showed up to. Nobody really seemed to be quite sure what client-server was, and at one point I saw the teenage text analogy. But it seemed like IBM did client-server the best, and that client-server solutions usually cost more money than you'd expect them to. I read about a year and a half of this weekly publication without being quite sure what they meant with client-server. They even ran a competition for an explanation of what client-server is. And here's the winning entry. And with the winning entry, I finally got it. Let's have a read, shall we? Let's first define an application. In this example, to drink. One alternative is to visit a liquor store, get a half bottle of vodka, and down it at your earliest convenience. This gives maximum effect, just like running the application on your PC. Client-server is to take your friends to a bar where you, the clients, are served with alcohol. It's the bartender's job to make sure that your glass is always full. And during times of high load, you can add another bartender. Meanwhile, you and your friends can focus on the drinking. So, what they're talking about are to us just regular server applications, where a client part running on your computer does some of the presentation. For example, a database, a web server, or whatever. At the time, this was, aside from running an application on your PC, also in contrast with the old way of doing this kind of centralized knowledge. A mainframe or mini-computer with a whole gaggle of dumb terminals connected, where both the server and client application would run on the same central computer. Now, if you weren't connecting up remote sites of a company, the killer app for getting connected was email. Email allowed you to instantly-ish communicate with other people and companies. This was usually done with a local mail system that was then connected to a national or international mail system using a mail transfer agent. Overall, businesses were moving away from mini-computer or mainframe-based email systems and towards PC-based solutions like CC Mail or Microsoft Mail. The mail transfer agent part of the puzzle was usually a service contracted out in order to get connected to the world. At this point, there were basically 4 different mainstream systems for international email, and I'll quickly go over them in order from least to most demented addressing format. First is Internet Mail. You know this one. User at host. The host bit tells the sender system what computer to connect to in order to deliver the mail. It's transported over TCP/IP on the internet. At this point, it was mostly used by universities and other research institutions, although business use was slowly increasing. In 94, the MIME extension was adopted for Internet Mail. This was a big deal in Sweden, as Internet Mail was not 8-bit clean, and there was previously no good way to use our national characters without resorting to obsolete modified 7-bit ASCII encodings. Next is FidoNet. The address is zone, followed by network, followed by node, and finally it might be followed by a mailbox number. Mail is transferred at a scheduled time of day, going up in the hierarchy from node, to hub, to network, to region, to zone. When it has reached the least common denominator of the destination address, it flows back down again. The transfer medium was bulk transfer over modem, usually late at night when phone calls were cheaper. Mostly operated by volunteers, it was used to connect BBSs together and was basically never used by commercial entities. 94 was during the peak of the BBS era in Sweden, so FidoNet was widely used. And after that, we got the UUCP. UUCP is another example of mainly bulk transfer email. The addressing format here is a so-called bang path. To send someone an email, you need to know which computers to route it through, Most computers used for mail had fixed schedules when they exchanged mail between a set list of different systems. There were catalogs available that listed schedules for the major nodes. International mail could easily need a dozen hops to reach its destination, and this could take over a week. This system was quickly being replaced by internet at this point. And finally, we get to X400. This is the system that the EU would decide to standardize on during the first half of the 90s. It was, even in 94, still touted as the future in Europe. All businesses would use it, government would use it, and basically everyone else that was important. It used this completely insane addressing format where you basically had to explain the computer system, network, and the user on it that you wanted the mail to reach. It also had a number of features like encryption and delivery receipts that wouldn't be bolted onto internet mail until later. This is basically where Sweden was heading in 94, both in public and private sector. We had multiple vendors for X400 services, including the National Phone Company, as well as the National Post Company. The latter charged 3 times as much for an email as they did for a physical letter. Internet mail was seen as a toy for universities, regular people, and maybe smaller companies that couldn't afford real email. Sending emails between these systems required the use of bridges that could, usually awkwardly, translate from one email system to another. Just look at how this user sends an internet mail from his X400 account. And somehow, this is the future. Aside from other email systems, there were also bridges for fax machines, telex, pagers, and other nonsense. This addressing format lives on with stuff like X509 public key certificates and LDAP directory services, which evolved from the X511 directory access protocol. And in a way, that's where we were in 94. If you didn't work or study at the university, you probably didn't have access to the internet. An internet connection of any kind was expensive and of limited utility. It was, however, to some very exciting. Our Prime Minister at the time, Carl Bildt, sent the then US President Bill Clinton an internet mail. After being phoned up by Carl informing him of the email he sent, Clinton replied. This made them the first 2 heads of state to communicate over internet mail. And to this day, Bill Clinton is remembered in Sweden. Not for the email, but for the mediocre Freezer pizza launched around the same time named after him. And those are named after Gorbachev. Bill and Carl weren't the only 2 celebrities you could pester over internet mail. There's also Bill Gates, Al Gore, the Pope, the then President of Vietnam, and Bill Clinton's cat. There's always been cats on the internet, hasn't there? Speaking of internet connections, there's a bit more to it than you'd think. At this point, internet access was divided up into 3 different levels. Level 1 meant email. You could, by some means, send and receive internet mail. Level 2 also gave you access to Usenet, which had moved over to the internet from its UUCP roots. Level 3 was the actual protocol access, but could give you access to services like FTP and Mosaic on the World Wide Web. At this point, the dominant browser was Mosaic, so the World Wide Web was often just referred to as Mosaic at this point. And this was something you could read a lot about in the press towards late 94. Websites. Various parts of public and private sector, researchers and just people in general were putting up websites front, left and center. It still wasn't quite possible to do business on the internet yet, with payments and all that, but there was still a bit of a scramble to make a presence online. The actual utility wasn't entirely clear yet, but it was very exciting. It wasn't until November that regular people in Sweden could pay a modest sum of money and connect their PC to the internet, when Sweden's first ISP for individuals, Algonet, opened up. It was still a niche thing, as this ISP originally had just one access number, which was in the Stockholm area, and their modem bank looked like this. By the end of the year, they had like 20 phone lines, 1,500 customers, and it was growing out of control, which should give you a sense of the scale of it. In fact, as most of the usage was either from universities or internet email, the entire branch of the Swedish internet, Sunet, ran on a 2 megabits per second backbone. The larger network, Nordinet, which also included Denmark, Norway and Finland, then shared a 1.5 megabit link to the US, which was nowhere near enough. Congestion was already a problem. Connections towards mainland Europe was also starting to be established, but resistance against the internet protocol was very much still present down on the continent. Meanwhile, a research network was set up here called the Stockholm Gigabit Network, at a transfer speed of 622 megabits per second. It wasn't intended as an internet backbone. It was going to be used for research around real-time audio and video transfers, as well as general research about the practicalities of running a high-speed network. Back then, it was often talked about the information superhighway. This was not just a metaphor for the medium where a large amount of information would flow, it was also a metaphor for the infrastructure we needed to build. Outside of businesses and government, the BBS was still king, and is what most regular people used their modem for if they didn't dial into work. In one attempt to reach out to more regular people, the government set up a few BBSs of their own, based on a proprietary graphical client called First Class, soon followed by every major political party setting up their own. I think the notable thing about it is that until 1994, the server portion of First Class would only run on Macintosh of all platforms. Other walled garden type of services didn't quite have a presence here, except for CompuServe. CompuServe was very expensive though, about $10 an hour, not adjusted for inflation, so it didn't see widespread adoption here. But now that I've talked a bunch about networking, let's have a look at some actual networking, shall we? To get my PC ready for networking, I first need to choose a technology. I'm going to use this NE2000 compatible Ethernet card with thin Ethernet network, also known as CheaperNet for its lower cost. On the software side, there's a few options for setting up a small network, like LAN-tastic and PowerLAN. But another option was launched in '93, Windows 3.11 for Workgroups. This adds network capability into Windows in a way that is easy to configure and offered a good value if you were just setting up a basic peer-to-peer network without a central server. It was also pointed out in media as the latest push from Microsoft to absorb market segments and dispose of competition. It's still reviewed favorably though. So I'll start by upgrading my computer to Windows 3.11. This process is pretty much the same as installing Windows 3.1 was. This went well until I got a disk read error right at the very end as it was configuring my printer. The setup crashed and I could no longer start Windows. I replaced the bad disk and tried to upgrade again, and now it was back. Aside from networking, Windows 3.11 for Workgroups does add a few other things, like the registry. But if you ask the calculator, well... But with Windows 3.1 installed, I can proceed with installing my network card. I'm starting to run out of slots, but there is still space for it. I start Windows back up and install the driver for it. It's included with Windows, so it's all straightforward. Then I get to this dialog, which is where I need to set the IO port base address and IRQ for the card. Now, this seems to have changed from Windows 3.1 for Workgroups. I'm fairly sure that on 3.1, what you put in this dialog is what the network card would get configured with. Not on 3.11, and it took me an afternoon of troubleshooting a resource conflict with my sound card until I tracked down a driver disk for my exact board. There I found a configuration utility that lets me set the IRQ to one that does not conflict with my sound card. This is also where I can select the type of cable I'm going to use. But with that, I've resolved the resource conflict. Now I just need a computer to network with. So I went and visited one. We originally had plans for a larger network, but we ran into some technical difficulties. So it quickly turned into that kind of party. Looking at the network card, we got 3 interfaces, 10 megabit twisted pair, the same type of cable and connector we use today, terrible in every way, chosen only because the US already had buildings full of category 3 cabling with these 8P8C jacks for telephones. This BNC connector is for thin Ethernet or CheaperNet, which is what we'll be using. Before twisted pair took over, this was the dominant standard for small networks. It uses thin coax and these T connections. They might seem familiar if you've seen the networking icons in Windows. The computers on the network are all just connected in one long chain, up to about 30 at most. At the end, you put on these terminators. Then there's the none of the above AUI interface, where a thick Ethernet transceiver could be connected. It looks something like this, but with a different cable connector. If you've just set up a small network with a few Windows computers, there's a few things you can do. The obvious one is file sharing. Windows for Workgroups allows you to share directories on your system to the network. And you can map these shares up as drive letters, which allows you to work with the data just like on a local disk. Aside from files, you can also share printers. So we dug out an old 24-pin dot matrix printer that the other computer will be sharing. One of those old fun ones with fan fold track to feed paper. I still need to install drivers for it on my computer. But with that, I can now use it as a regular printer. I'm not sure why, but when used as a bitmap printer like this, it's very slow. But it works. Compare this to it running as a line printer, printing text. Another thing you can do that might be useful in a small office is local email. All you need to set it up is some computers with Windows for Workgroups and a file share to put the database on. And that's really all it takes to have a local email system set up. There were mail transfer agents available to bridge this system to other networks like UUCP or Internet Mail. This is all useful and all, but another use was multiplayer games. So we set up a Doom co-op game over this cheapnet cable. Me playing on a 386 is gonna need all the help I can get. There's a little bit of setup to get the IPX stack up and running in DOS, but we found a kit from the time that collected all the bits. I don't know if there's much more to say about it. It's Doom, with multiple players. But you didn't even need a network like this for 2-player multiplayer. Modem play was a thing, and so was null modem cables. This example here, Wacky Wheels, allows for 2 computers to be connected over serial. Aside from race, it also had a bell type mode. Back to networking, there's a few things to show on Linux as well. Up until now, all networking was done with the IPX protocol, which changes now. Linux didn't really support IPX at all. I didn't have the Ethernet card in my system when I installed Debian, so I have some manual configuration to do. I don't know where that configuration goes, so I just put some commands into rc.local. Something I'd like to try is to access files of a Windows share from Linux. I found this slightly dodgy kernel module that should let me do that. It builds entirely outside of the kernel, but it needs some non-standard kernel symbols, so I still need to recompile my kernel. But with a new kernel, I can build a module, insert it, try to mount the share, which doesn't work. This had me stumped for a moment. But apparently, you need to connect using the hostname and not just the IP address. A quick change in etc host later and... is it supposed to hang? Oh, it worked! I think all the network share stuff happens in the user space binary, and the kernel module is just glue. A bit like how Fuse works on Linux today. Going the other way, sharing files to Windows was also possible, as the Samba project was already up and running. It even got some publicity for working better than the commercial offerings. With a network up, my computer can also be logged into with RSH, which the system is set up for out of the box. This allows programs to run on my machine with the user at another computer. And since X11 is network transparent, programs running on my computer can show Windows on other computers. Magnificent. With a weekend of coax LAN behind me, it's time to look at modems instead. Back in the 92 season, I used this 2400 baud modem. That thing was horribly slow, so I got this used 14.4 kilobits per second modem instead. The fastest modem available were like twice the speed of this, but modems were expensive. So what will I use it for? Well, I'm really excited about the built-in fax functionality of Windows for Workgroups. To set it up, I just need to tell Windows that I have a modem on one of my COM ports and what my phone number is. Windows will automatically answer incoming calls. And then it will just start receiving the fax. Fax messages then arrive in Windows Mail. Since this is a new fancy modem, it can do group free fax, which is digital and essentially lossless in comparison to analog fax. While fax was the thing I was the most excited about, there's also this internet thing. It was in the news quite a bit, and especially the World Wide Web was starting to attract a fan base. Like that cybercafe that opened in the UK, which was one of the first internet cafes in the world. With the internet catching on, ISPs offering reasonably priced internet connections started popping up everywhere. Since Windows for Workgroups didn't include an IP stack, and the one Microsoft offered didn't support dial-up, it was common to use Trumpet WinSock for dial-up internet. If you got it as part of a connection package, you'd also get something called a chat script which set up the connection for you. I'm just making this up as I go, so I'll take the long route, doing everything manually. First, I set up the IP address I'm going to use on my computer. Next, I send it this init string to my modem, so it doesn't change the serial port speed after it connects. I found it in the manual. Then I can dial the number. Once connected, I just need to log into my account. My account is set up to start the sleep session automatically. And then I just need to tell Trumpet WinSock that I'm done and I can start surfing. So where will I go? We don't have the luxury of shovelware CDs, those never had websites on them. The Wayback Machine wasn't a thing in '94, so basically I need to find a website from back then that's still up. And after looking around for a few hours, I think I found one. And here it is, loading in Mosaic, the browser that made the World Wide Web accessible and exciting, pretty much. It's taking quite a while. This version of Mosaic doesn't present the page until all the resources on it has been loaded. The page itself is a behind-the-scenes story from when a news crew showed up at Linköping University to have a look around and talk about the internet. Embedded with the text is a whole bunch of pictures, which is why it's taking so long to load. Apparently, the news crew was very interested to hear how this technology could be used to spread porn. If we instead look at the page with Mosaic Netscape, you can see it showing the page while loading the embedded pictures. Clicking the pictures takes us to a higher resolution one. You can't however get away from the fact that it is quite slow. Netscape could show a number of media files, and more could be added with plugins. One such plugin that was gaining some hype was VRML, which promised to add virtual reality capabilities to the web. With the ongoing cyberpunk revival, I'm sure that was really exciting. You can also use Netscape for other protocols like Gopher and FTP. So let's jump onto an FTP site. In '94, the largest by far in Sweden was Sunet. It basically tried to mirror everything worth downloading on the internet. Back in '94, it had about 34 gigabytes of files, making it one of the largest FTP sites in the world, both in terms of archive size and traffic volume. I pulled down all the files left on it from '94 and earlier, and only got about 8 gigs of files, so a lot has been removed since. The FTP interface presents a basic file listen type of view, where collections can be navigated. Files that Netscape knows how to render can also be shown directly in the browser. That's cool. I wonder how much harder this will be on Linux. I'm going to use a utility called dip to connect. This program is a lot easier to use with a script to initiate a connection, so I'll take the time to look at an example and rewrite it for my connection. And it took a few tries, but I got there in the end. I wasn't sure how to make it do tone dialing, so it's pulse dialing instead. My phone line simulator isn't super into that, but it works anyway. And with that, I'm online. Dip automatically sets up the SL0 interface for my SLIP connection. Netscape is also available on Linux, so I can use a similar version of that browser. In the README here, you can see that Mozilla has been a name involved since the very start. When starting it up, I get a bunch of font errors, likely because I skimped out and only installed the bare essentials of fonts to save disk space. This is likely to be the reason why it doesn't render headings and such like you'd expect. In general, it behaves pretty much like the Windows version, which isn't surprising given that it's based on Mosaic, which was originally developed for Unix and later ported to Windows. And unsurprisingly, FTP works just fine on Linux as well. As an example here, I downloaded this file. There's no fancy file transfer dialog in this version of Netscape, just an anonymous progress bar in the status field. These .au files are easy to play back on Linux, just cat them into dev audio. But with this bit of success, I think this will do for this video. Check back next week when I'll be receiving pictures of the Earth from space with my 386. Until then, thank you for watching.